Hi, my name's Keith Milner, and in this lesson I will be explaining the 5 most important modules used in synthesis. These modules are oscillators, which generate audible tones such as sine waves and sawtooth waves, envelope generators, which generate a varying output level, usually controlled by the note on and note off events, amplifiers, which control the audible level of the input signal. These are often controlled by the envelope level or an LFO. Filters, which allow us to shape the sound to control its timbre by removing or boosting specific frequencies. An LFO, which generate low-speed cyclic patterns which can be used to modulate other parameters in the synthesis. I'm going to be demonstrating these building blocks using a package called Alsa Modular Synth, which runs under Linux. And the advantage of it is that it actually allows you to see all of the individual pieces that make up a synthesizer, and you can actually wire them up in different ways and be very, very creative. I've wired this mostly as a standard synthesizer of the type that Loudon was talking about in the lectures. So the MCV here represents the keyboard, and it has a note on and off or a gate, and it has a frequency which represents the note being pressed. We have a voltage controlled oscillator which is driven by that frequency from the keyboard, and that's driving a sawtooth wave. And we have an envelope generator, which is driven by the note on, note off. And we have, here's the envelope definition, and we can change the attack time, the decay time, the sustain level, and the release time if we want to. And that drives a voltage controlled amplifier. It controls the gain. So as the gate fires, that creates that envelope, which drives the VCA gain level to follow that envelope. And the output from the VCO, we're taking the saw wave output into the VCA, and so what we end up with is a pulse of the audio output from the oscillator, which is controlled by the envelope and the VCA. So if we press the keyboard, and so we have now a basic synthesizer. However, that's not very interesting because we kind of want to be able to shape the timbre of that a little bit. So I'm going to disconnect that output and I'm going to connect into this VCF and connect the VCF output here. And now if you press it, then you'll hear it's slightly different. I'm going to change that to a low pass filter because it was actually on a high pass filter. And we can change the frequency of that to change the timbre. The final thing we'll look at is the LFO, or low frequency oscillator, which outputs a very low frequency waveform. In this case it's around about 4 Hz, but I can adjust it to make it slower or faster. So if I connect the LFO sine wave output to the frequency control of the VCF, it will basically sweep the filter's frequency range up and down in a sine wave pattern according to the frequency of the LFO. So now, if we try that out, and we can adjust the frequency either faster or slower. So that gives us a lot of control. So as you can see there, we've created some tones using an oscillator. We've used the envelope generator and the voltage controlled amplifier to actually shape that and control the note on, note off, so that we end up with an output which is tracking the keyboard. We've filtered that with a voltage control filter to give us the ability to change the timbre, and we used an LFO to add some modulation, in this case for the frequency, but LFOs can be used for all kinds of purposes. They can be used, for example, into another VCA to control amplitude, which could give us a tremolo effect. To end with, I thought I'd show you one of the demonstration files that comes with Alsa Modular Synth. This is a much more complicated setup with a number of other components such as limiters, quantizers, noise generators and so on. This doesn't actually use the keyboard itself, but it actually self-generates music using internal triggers. Let's hear how it sounds. So I hope you found this informative and interesting, and thank you for watching.